Gettering is a method in which minute crystal defects and distortions called Gettering sites are intentionally formed in or on the backside of a silicon wafer to capture metal impurities such as copper and nickel. Due to the loss of Gettering sites, conventional thinning methods cannot capture metal impurities such as copper and nickel, resulting in adverse effects on device function. This video introduces the mechanisms that cause adverse effects on NAND flash memory and their countermeasures. Relationship between Gettering and metal impurities in NAND flash memory. NAND flash memory determines whether data is 0 or 1 based on whether or not there are electrons in the floating gate. Electrons in floating gate. Electrons not in floating gate. Metal impurities such as copper and nickel around the floating gate become a path for electrons, causing them to leave the floating gate. This prevents the NAND flash memory from maintaining the zero state, meaning electrons are present, which results in the state being misinterpreted during data reading as the one state, meaning no electrons are present. In turn, this issue prevents the data from being retained correctly. To prevent this malfunction, metal impurities such as copper and nickel need to be captured before they approach the floating gate. Wafer thinning and Gettering. During wafer thinning using grinding. Distortions formed on a wafer backside during grinding act as Gettering sites. Metal impurities such as copper and nickel are captured by Gettering sites, which prevents memory malfunction. Stress relief and Gettering. With devices becoming thinner, higher die strength is required. Thus, stress relief is performed using polishing after thin grinding. Standard stress relief removes distortions formed during grinding, which leads to poorer Gettering performance due to the loss of Gettering sites. Gettering dry polishing. After thinning using grinding. Gettering dry polishing makes it possible to combine Gettering performance and high die strength by removing processing imperfections while retaining minute polishing distortions. Metal impurities such as copper and nickel are captured by these Gettering sites, which prevents memory malfunction. When a forced copper contamination evaluation was performed for the wafer after dry polishing and Gettering dry polishing, it was confirmed that a Gettering effect can be achieved through the minute processing distortions formed by Gettering dry polishing. There are three types of Gettering dry polishing wheels: GA, MZ, and BP. The GA wheel is the standard wheel, the MZ wheel improves die strength, and the BP wheel is for wafers with bumps. The forced copper contamination evaluation confirmed that the Gettering effect can be achieved with all three types of wheels, GA, MZ, and BP.